Guys, so today we're going to have a look at area, and particularly how we get the area of squares, rectangles, and parallelograms. Okay, so the area is the amount of space that a shape covers, a two-dimensional shape, a flat shape covers. And the perimeter, remember, that was the distance all the way around the outside of a shape. Okay, so let's have a look. So here's a little shape drawn on a grid. And usually we can think about squares making up an area. If we can count the number of squares in a shape, we can say that shape covers that number of squares. And if each one of these squares is 1 centimeter by 1 centimeter, then we can say that we are dealing with an area in terms of square centimeters. Okay, so if I bring my laser pointer, if that's a centimeter there, and that's a centimeter there, this little square in here has an area of 1 square centimeter. 1 square centimeter. And we can count up the number of squares to work out the area. We can see there are some full squares in here. There's one there, and then there are 5 across the bottom. And then we've got these half squares that are appearing on the side of the shape. So we're going to think about these two together make an extra 1, and these two together make an extra 1. So let's just mark the slide up so we can see what we're doing there. So we've got 1, 2, 3, 4, 5 complete squares there. We've got 6, 7 complete squares there. These two come together to make square 8, and these two come together to make square 9. So if they were centimeter by a centimeter, each square is a square centimeter, so we're going to get 9 of those square centimeters. Okay. Not always going to be that straightforward. Sometimes we're going to have shapes that look a little bit odd, like this one. What we're going to have to do here, well, probably all we can do is to estimate what that area is going to be. We've got some full squares again that we can quite easily deal with, and then we're going to have to think about building up some squares to go together that might make pretty much a full square. So as an example, let's have a look. Maybe this little bit here and this bit inside here, maybe they make a full square, so we might count them. We're only going to be able to get a rough estimate as to what that is going to be, though. Some shapes we can get the areas of really nicely and easily. So here we've got a square. This square is 1, 2, 3, 4, 5, 6, 7 squares along, and it is also 7 squares down. It wouldn't be a square unless it was the same number across as down. So its length and its width are the same. Now I could count up all the squares inside there and figure out how many square centimeters that's covering altogether, again, if these squares are centimeters. But I can do this a lot quicker because I can see that every row that I'm dealing with in here has the same number of squares in it. I've got 7 here, I've got another 7 here, I've got 7 here, I've got 7 here, and so on. So I've got 7 times 7 squares. Okay, just that easy. So if I'm dealing with a square, all I have to do is take the length and times by itself. How wide is it? 7 sevens are 49. 49 square centimeters. That's done it. Okay, remember, we're talking about squares. It is 7 squared. What does 7 squared mean? It means 7 times 7. We just times the width, the length of the square by itself. We're squaring it. So if we look at this square here, okay, this is 5 centimeters. We're told it's a square. That is also 5 centimeters. How do we get the area of it? We do the length times by itself. Because we were told they were centimeters, when we've done that and got our 25, we have 25 square centimeters. That's its area. Okay, nice. Onto a rectangle. Rectangle's very similar. What we got here, though, we've got 1, 2, 3, 4, 5, and 6 squares across. And going down, we've got a different number. We've got 5 squares going down. So how many squares would we have altogether? We would have, looking at each row, we've got 6 in a row. We've got 5 rows. How many altogether? We got 5 lots of 6. So 5 lots of 6. And if each one of those is a centimetre again, the area will be in square centimeters. If they're in meters, it would be in square meters. If it was a kilometer even, it would be in square kilometers. But if we say they're all centimeter squares, it's 30 square centimeters. Okay, so let's just bring up another one. 31 and 9. Well, we know we just have to times them together. 31 times 9. Okay, a couple of ways to do it. You could do 9 ones and then 9 threes with a 0 on the end. Or maybe we do 31 times 10, because we can do that easily. That's 310. Times by 9 is not quite so easy. Just add a 0 on the end. And then we need to take one lot of 31 away from that, because we only wanted 9 31s, not 10 31s. Taking 10 away is easy. That takes us down to 280. Then we've got another 21. Sorry, it takes us down to 300. I'm jumping ahead. Taking 10 away would take us to 300. Then if we take another 20 away, it would take us down to 280. But we had 21 to take away, so we'll get to 279. And again, we told they were in centimeters, so that's square centimeters. All right, just the length times the width for a rectangle. And then we've got our final shape for today, which is a parallelogram. Parallelogram has two pairs of parallel sides. These sloping sides are parallel, and these lines going across are parallel. But how do we get the area? Well, we could add up all the squares, but it's a bit awkward to do that. Again, we've got some that are complete, we've got some that aren't. So if I bring my pointer back again, yeah, we've got a little bit of one there and a bit, maybe these two are going to come together, maybe other ones are going to come together, but it's a bit messy. And there's a much nicer way for us to think about doing this. Okay, so if I think about drawing a line down here, I'm going to cut this triangle off the shape. Okay, and I'm going to move it. I'm going to slide it along so it goes here. Now look, the length there was 3, and I've got a length here of 3. It will fit there nicely. The height of that triangle was 4. The height that I've got here is 4, so it will fit nicely. So my triangle has just slid across into that place. Now what am I left with? Well, because that's moved, I've got, if I just draw it roughly, I have got a rectangle, haven't I? I've got a rectangle. My parallelogram has made a rectangle. I know how to get the area of a rectangle, and it must be the same as the area of the parallelogram. So all I've got to do is work out how far across it goes. So here we've got 1, 2, 3, 4, 5, and then how far up that went. Okay, so it went 1, 2, 3, 4. Okay, 5 times 4 is 20. And again, square centimeters, if these little squares are a centimeter by a centimeter. What have we done really? We have done the length of my parallelogram by this distance here, the height of the parallelogram. Nothing to do with this side length, nothing to do with, let me switch my pointer so I can do that a little better. So we've done this length here times by this distance here. Yeah, the 5 times the 4, the length times the height. This side length here doesn't have anything to do with it at all. It's the length times the height for a parallelogram. This is a little right angle here, look. Little right angle here in that corner. Length times the height. So let's just bring that up. We're trying to look at this question, 4 and 8, and we've got a 7. This 7 doesn't matter at all, does it? The 7 doesn't matter at all because we only need the length and the height. That's all we need. So we don't need that confusing 7 at all. It's put there just to see if we know what we're doing. Do we know what we're doing? Do we know what side lengths are important in this? Do we know what distances are important? We know it is the base length and the height. So all I have to do for this one then is the base length, which is 8 times the 4. 8 times 4, 32 square centimeters. And we're done again. Okay, so we've done 3 things today. We've done the area of a square, just times the side length by itself. So if the side length was 5, do 5 times 5. The area of a rectangle. So if we need to do a rectangle, we can just times the length by the width. And if we want the parallelogram, like we've just done here, we do the length times by the height. And we're all done. Have fun on the lesson, and I'll see you next time.